Good afternoon, ladies and gentlemen. My name is Felipe Corlaleri.
I'm Krishna Acharya.
And I'm Bruno Cortolari. Tonight we'll be talking to you guys about the science of toys. The outline for this project, tonight we're going to be talking to you guys about the background, the project description, the stakeholders of the project, also the specification requirements set by the company, the conceptual designs that the group came up with, and the decision matrix of all the toys, and also we'll be discussing the next steps moving forward. And at the end we have a time for you guys to ask any questions.
The background for this project is, this is the project for senior design class. In this class we deal with design as well as redesign of an operation or product or any design that comes in this project. In this project we are assigned to one of the local companies, Putnam Science, which is Putnam Science Museum. Our main project is to come up with at least five or six toys and determine science of toys as well as determine how it works. So main course objectives will be, obviously we are working with different local companies, so we need to know how to communicate effectively, and we'll learn how to do the time management as well as how to work in a team. And since we have a limited budget, how to work under the budget is also one of the course objective. Since this is a senior design, we are going to apply all of our knowledge and skills that we have gained so far in our 4 years career as an engineering student. So we'll apply engineering knowledge, and one of the important objective or knowledge we are going to use is reverse engineer and find out what is the science behind the toys. Our project description is, we are working for the Putnam Science Museum and we are going to create or design 5 or 6 ideas, and we are going to submit those ideas for them by the midterm. Once we submit the ideas, we'll find out which two of the toys we are going to work with, and we'll move on after the midterm on those 2 toys. Main thing we are going to do is determine the science behind the toys which we used to play in our childhood, and these toys will be presented to Putnam Museum staff, of which are about 4 to 6 displays, and they are going to select 1 or 2 that are going to be used in the exhibition.
The stakeholders for this project is the engineering science in the physics department of St. Ambrose University, which includes Dr. Lutt and Dr. Shi. Also the group that's talking to you, Felipe, Bruno, and Krishna. Also on the Putnam Museum and Science Center staff, and all the users that will be going to the exhibition.
Specification and requirements. On our first meeting with the Putnam leadership, they gave us some requirements for when we came up with the ideas. One of them was accessibility. Since many type of people go to the museum, it has to be in a certain height where kids in wheelchairs or adults, any kind of people can reach it and play with the display. It has to be safe, so that means no loose wires or shock hazards, or even avoid sharp corners, cutting objects, because the kids are gonna be playing there, so we cannot just put a knife so they get hurt. Another specification where it has to be self-explanatory, since there's not gonna be anyone to explain it like 24 hours there. The targeted age is for kids between the age of 8 and 13. It has to be durable, since the display is gonna be there for a year. And it also has to be hands-on and colorful, so it attracts the kids to play with them. Our first idea was the Hape Lily musical push-along, seen in this picture here. The science behind it is the cam and followers, and a cam and follower mechanism is a profile shape mounted on a shaft that causes the follower to move. The cams are used to convert the rotary motion to linear motion. Here are some examples of cams and followers. In this case, the cam would spin and cause the green follower to move up and down. The display would be a banner with the information previously discussed, and the toy built out of plywood would be mounted on the banner, where the visitor would spin the transparent wheel and see the cam affect the height of the wing. The measurements can be seen in the following picture, but it can also be adjusted moving forward. The second toy we came up with that was the Caterpillar Automata, which follows the same principle of the Canon followers. It can be seen here in the picture. The display will be similar as the first toy, with the banner with the information and a large size version of the toy, where we will include 3 different types of cams: the eccentric, the pair, and the circular. The visitor will be able to exchange the cams to see how the shape affects the movement. For example, if they put all circular type of cams, the caterpillar would stay in the same height as the spin, but the eccentric will give the impression that the caterpillar is moving. The real-life application of camshaft is the camshaft, which controls inlet and exhaust valves of internal combustion engines. It consists of several radio cams, each displays the intake and exhaust valves. The GIF here shows how the cam spins, causing the inlet and exhaust valve to move up and down. And an example of camshaft can be in the second picture.
The third display that the group came up with was the toy the pullback car toy, which utilizes the spring and gears. You can see in the video here how the engine of the car consists of all gears and springs, and once you pull back the car, it rotates the spring, which you can see right here in the video, and once you let go of the car, the spring tends to go back to its original position, making the car move forward. There are a lot of real-life applications for gears and springs. One of them being for gears, the bicycle gear. Once you pedal your bicycle and you want to make it easier or harder, you can change it. And for springs, you can find them on your car suspensions. For the display, the group came up with, for a fun and educational way, you can see it for a fun way, the racetrack. There will be a 3 to 4 lane racetrack, which families will be able to race each other and have fun while doing it. And for a more educational way, there will be a large size transparent engine with a wheel connected to it. Once you rotate the wheel, you'll be able to see all the gears and spring rotating, and once you let go of the wheel, it will make the wheel turn, simulating as the car is moving forward. Also, there will be real-life application examples with gears or car suspensions or a bunch of other ideas that you can set up there. And also there will be a banner with all the information necessary for the kids to be able to understand better the process.
Another toy that our group came was racing car in a slot track, which looks like this in the figure. The main science behind this slot car is Ohm's law, and which is one of the most important law in electricity and magnetism. The law basically says that the potential difference across 2 points, such as we can connect the current or voltage any 2 different points. The potential difference between those 2 points is the product of current through the circuit and the resistance on the circuit. So in this figure we can see that each slot car, in the slot car there are tracks. So in each track there will be only one car. The car will race each other. So in order to make it more interactive, we can make this track slot with different tracks, at least 4 or 5 tracks, and there will be 4 or 5 cars running in each track. And each track, underneath the track there is a conductor. When it is a complete track, it makes a full circuit, then the electricity flows through it, making the car moving forward. And the car itself acts as a resistor, and if we use some kind of remote control, it will also act as a resistor, which can make move faster or slower based on how hard we press the remote. Buzz Frank Perry, he is a proprietor of the Buzzerama, who has been working in this slot car engineering for a long time, and I want to show his video, and he also explains how this slot car works.
Survivor. They have 12-volt DC motors in them and a guide flag that fits in the slot, and when you hit the hand controller, it energizes those lanes and gives the motor juice. The fastest cars can go upwards of 100 miles an hour. So they're like blurs now. You have to hear them. You go, wing, wing. You can hardly see them. You have to listen to them. You go, wow. Kids play with computer now, and there's no interaction with it anymore. Over here they have an interaction with other drivers. They compete, they congratulate each other. You learn sportsmanship. It's real.
As you explained in the video, that rather than just playing the computer game or video game, this allows kids to interact with each other because they are competing with each other friends and who are competing in the slot track. Next one. This figure shows the basic component of the car. Everything is same. There's wheel, motor. The only new thing in these slot cars are there's a magnet here and there's also the motor cable and guide which will guide this car only through the slot track, and that this acts as a conductor, so it conducts the electricity which are in each slot and making the conductive wire. And display, when we visited the Edward Creative, who is also the partner in manufacturing with the Putnam Science Museum, so we learned that they can make a prototype or they can make a whole setup by making a display with the screen and giving the each step-by-step instruction to the kids or anyone who plays this. And we also learned that they can make a screen where they can show video on how to play and how to display or how to show it how it works. And can you go back once? So in order to make more interactive, we can also use two different methods. One, we can just build fully designed track, or we can also use another track where children they have to assemble themselves. Like for example, in this color-coded track, each track has its own size, so children they can make it their own track based on the given color. So they can just join this part, and other part. But as long as they make a complete track, there will be a complete circuit, so electricity flows and the car can run. And we thought that this could be more interactive, so we just designed this track, but which are apart, and children they can assemble it themselves, and then they can play themselves. And since this is electricity, this runs on the base of ideas of electricity. The main ideas is that electricity is used everywhere, so it has application in everything, even in our computer, cell phone, even these presentation slides, everything has electricity. So anything that runs with circuit, we use pretty much in everyday life. So children, they'll have good idea of knowledge of this Ohm's law. That means they know how everything electricity works in our daily life.
The last display that the group came up with was the Beyblade, which applies the Newton's first law of motion and the law of inertia and torque. The display of this toy will be pretty simple. Will be a tabletop with different sizes, different materials, and different colors of Beyblades, which they will be able to play with. And also with the information given, they will be able to realize how the material and size affects how the Beyblade spins.
To add more into that, first law of motion is just that an object tends to stay in its position either at rest or at motion unless an external force is applied to it. For example, this football, a soccer ball which is at rest in this position, unless an external force by the leg is applied on it, it just tends to remain in rest forever. And once he applies the motion, like the force, the ball moves, and it tends to move forever unless an external force is applied by ball net or air resistance or something. And when we talk about the inertia of the motion, like this blade, it tends to rotate as much as possible based on the mass. So the more the mass, it will rotate the faster or for a longer time. So that's why we say that it depends on different types of material. If it is made up of metal, it tends to rotate for a longer time, and if it is made of plastics or other rubber, it tends to rotate for a smaller time.
Decision matrix. After we came up with all the ideas, we chose 4 criteria to how to judge all the toys. We chose safety, accessibility, self-explanatory, and hands-on. We gave weight to each of the criteria, and safety, in our opinion, was the most important factor, and accessibility was the second one. After that, we scored each of the toys in a scale from 1 to 5 and multiplied that result by the weight to get the total points for each of the toys. After doing that, we realized that the pullback car toy was the toy that best followed the stakeholder requirements, and the Beyblade was the one that least followed those requirements.
Moving forward, we are going to work on 2 specific projects that the Putnam Science Group that chose among our five designs. We were supposed to present this in front of Putnam Science Museum, but with everything going on right now, we are unable to present in front of them. However, we are expecting some feedback and suggestion from the video, like from the ideas we submitted them through the midterm report. So once we get those 2 ideas which they want to do us, we are going to work further more on that. We are going to do more research, and we are going to give a final preprint, and then they can create design and display for their toy exhibit. If you have any questions, feel free to send us email. Thank you.
Thank you.